my speaker notes. Oh, I'm totally failing. This is terrible. All right. So Amazon Web Services. Amazon, long ago, started a online store for buying stuff. As Amazon grew and grew, they needed a big amount of infrastructure to be able to support their internal services. At some point, they decided that, given the way they had built up their infrastructure, that they would be able to start selling their excess capacity to end users to be able to launch their own things on Amazon or on the internet. So the way they had built their services was really centered around APIs. Everything had its own API for launching, for spinning up new instances, for all these different services. And it allowed people to easily put their own things out there in their virtualized environment. So, so what does Amazon provide you with? They really have I don't know, there's like 60 or 70 different services they have. They have CloudFront, which is a content delivery network. It allows you to put your assets, your JavaScript, your images, things like that have them cached at like the edges of the web, nearest to your people that are going to be utilizing them. They have RDS. RDS is a relational database service. It's based on MySQL, but it allows you to have access to a database that you don't have to manage yourself. They manage it for you. You say, I want an RDS instance. They give you an instance, and it's just all set up. You don't have to manage the database yourself. EC2, it's their Elastic Compute Cloud. These are just raw server instances that you can spin up and do whatever you want with. You're basically in charge of them. You have raw metal, like they're just virtualized instances on Amazon servers that you have Red Hat Linux or whatever ISO you want to spin up. You can put whatever you want out there, and you're in charge. They have ELB, which is an Elastic Load Balancer, which is a way for you to have multiple instances behind a single point of entry, and it manages pushing the requests that come in to various servers behind the scenes, depending upon how heavily loaded they are. Round robin, you could choose how it goes ahead and does these things. So what are some of the good things about AWS? There's a very low barrier to entry. You don't have to buy any servers up front. You don't have to buy any networking equipment up front. You don't have to buy rack space. You can have an instance from like the smallest instance that's got about the processing power of your phone up to these super computer-sized 32 processor, 200 gigabytes of RAM. You don't have to put that money up front for you to be able to have access to these things. You as a person can go to Amazon and say, give me an instance, and you just start paying hourly based on how long you use this instance. They have so many different types of services. We just talked through some of them, but there's a lot more. And they all interoperate in some way. And you don't have to worry about maintaining all these services. This is also a big benefit. There's no maintenance costs. Amazon's worried about if servers go down, if drives fail, if networking cables fail, all these different things that could happen. Amazon has put the engineering staff and the thought into making their services resilient. So you don't have to actually go through and manage these things by yourself. That's a lot of cost savings up front. So what's some of the bad? To begin with, you're dependent upon Amazon for their upkeep and maintenance. You're trusting this large company out there to maintain their equipment. They're likely going to do it. They have a lot invested in keeping their equipment safe and whole and reliable. They have data centers all over the world. You could choose which regions you want to deploy to, et cetera, et cetera. But you are dependent upon this other company. It's not in your own control. You can't go out and touch these servers and hit the power button. They're out there and in the cloud somewhere. It can be expensive at scale. There are studies that have been done. It ends up being less expensive to have your own data center that you're paying for in-house and maintaining those servers by yourself. But then you have to worry about having staff to maintain these servers. You have to worry about the servers breaking, all these other things that we talk about as the good side of it. it ends up becoming more expensive for you if you have large websites to be able to keep them up and run them on Amazon. It's a trade-off as to where you want to put the money. Do you want to put it into capital expenditure? Do you want to put it into staff to keep your servers alive? You're also sharing these resources. So these servers they're virtual servers. They have large machines at Amazon that they're portioning out pieces of them, and you're sharing CPU time. You're sharing all the resources, basically. It's invisible to you. You don't see this. Once in a while, you'll see like some of your CPU is being stolen on some of the smaller instances, and you're not getting, like, you go to use something and it slows down a little bit. It's not generally an issue, though, depending upon the instance size that you have. Same thing goes with drives. A lot of the drives that Amazon used to have on their instances were what they called EBS volumes, which it stands for Elastic Block Store. They're basically virtual drives that were connected through networking cables to these instances. They've since recently added the ability to have SSD drives on your instances themselves, which are basically directly connected to those instances. So you have SSD speed, I/O locally on your machines. And the ugly. So you're basically getting your own set of instances here. You become the systems administrator. You become the network administrator. You're responsible for security. You're responsible for ensuring that your system is patched, all the packages are installed on them, et cetera, et cetera. You have to think through infrastructure challenges, like how are you going to connect your instances together? How are they going to talk to each other? How many database servers do you need? Things like that. And you really become the sysadmin. You go from being just a developer to being a DevOps person, where you're the sysadmin, you're the netadmin, you're the developer, you're doing all the work. So how do you go ahead and get code out onto EC2? You've decided you want to make the jump to EC2. You want to have your own instances out there. How do you do it? So you could just go and say to Amazon, I want an EC2 instance. Choose what instance size you want. Spin it up. The machine comes up. You choose one of their many, many different operating systems that you could use. And you get a blank, raw slate. You do what you want with it. Again, you're the sysadmin. You have to decide, what packages am I going to install? Am I going to install Apache? What version do I need? Am I going to use Nginx? All the different bits and pieces you need to make your server go, you need to do. You're going to be installing gems. You're going to be installing versions of Ruby, things like that. There are system packages that you can utilize. You can use Debian packages or RPMs to do this, but you're doing it by hand. And then how do you get your code out there? You have this system, it's ready. Now you have to somehow get your code there. Do you log into the machine with SSH and do a git pull from your GitHub repo? What do you do to actually get your code onto the server? And then once it is on there, how do you make it available to the world? If you have 5 instances, how are you exposing them to the world? Do you have the Elastic Load Balancers that we spoke about? You have to manually add each of these instances to an Elastic Load Balancer to get them to be seen from the outside world. So a couple of years ago, Amazon came up with a new service called OpsWorks. And what OpsWorks does is it bundles a few of their services together. It bundles together EC2, which provides you with an instance, and it adds on top of that a layer of management using Chef. Chef is a configuration management tool where you actually write code to configure your servers. There's a few different options in the configuration management world. The 2 top ones are sort of Chef and Puppet. AWS went with Chef. Chef is written in Ruby. It's Ruby code. It'll feel familiar. They've written sort of a DSL using Ruby, and it handles a lot of the heavy lifting for you. When you spin up an instance in OpsWorks, there are Chef recipes that go ahead and install the base level packages. They make sure that your system is up to date. Depending upon which layers you're deploying to your OpsWorks instance, it's going to install Apache for you. It's going to install Apache modules for running Ruby, things like that. So, yeah. So there's a few different parts of OpsWorks, and from this point forward, I'm going to sort of live code at the same time. I'm going to go into and actually deploy an application in OpsWorks step by step, so you can follow along and see what's happening. So OpsWorks starts with the concept of a stack. A stack is the top level thing that you build in OpsWorks. And a stack is basically an application coupled with an environment. That's the way that I use it. So I'll have my application, which in this case is going to be an application called Hello DBCx, and it's going to be deployed in a production environment. It's really just a way to group together a bunch of resources and keep them separate environment-wise from production, development, etc. A stack is going to have can have one instance. It could have a number of instances in it. If you're developing, if you want to think about it the way that you work, your development stack currently is your laptop as a developer. Your laptop has a database server running on it. Your laptop has a web server running on it. It might have a memcache server running on it. So when we get into deploying things in production, we're going to put these things on individual servers. And depending upon how many people are going to be hitting your server, you might have more than one instance serving your front-end web. You might have 2 or 3 memcache servers behind the scenes. You might have a large database server. It really depends. So let's go look at making a stack. So this is the Amazon EC2 or OpsWorks. This is the Amazon set of services that are available to you. There's a lot here. We spoke about EC2, which is over here, and OpsWorks, which is right here. They put it under deployment and management. It's a management system. So if I go into OpsWorks, gives you this nice introduction page. We're going to start fresh and make our own stack. So we're going to name our stack. I'm pretty much going to leave the rest of the things default. You could choose which region you want it to be deployed in. The majority of things in EC2 get deployed to US East. It's like their primary data center. But if you're targeting people in other parts of the world, you could choose a different data center as your primary location. Your stack can have instances from different data centers. So we're going to keep it as US East. I'm going to change this to Ubuntu. I like Ubuntu. I'm going to leave everything else the same. So now we have a stack. Okay. So stacks have layers. Layers are groups of servers which do a single thing. You could have a Rails app stack. You could have a PHP app stack. You could have a database. Layer. You could have a Rails layer, a MySQL layer, a PHP layer, a memcache layer. Amazon provides a number of different layers as default for you. If you can fit your app into the layers that they give you, and if for a Rails app, it's straightforward. It makes it a lot easier. So let's see. And you can customize the layers through using Chef. So Chef is this language that we spoke about that does the deployments. Chef allows you has a bunch of different variables for each recipe that you can choose to use to override different settings in the way that to get away from what the defaults are that it comes with. You don't have to. For the most part, if you're just deploying a Rails app, you can just leave things the way they are. This app is going to have just a Rails layer. We're going to add that. So we click on the add layer. It asks you what type of layer. They have a few. They have a load balancer layer, HA proxy, static web server, which is just Apache. It might be Nginx. I think they give you both options of Nginx or Apache later on. We're just going to deploy a Rails app server. It's going to ask you which Ruby version you want to base it on. Go with 2.2 and do Nginx and Unicorn. It'll call bundler for you. So if your app has a gem file, part of the deployment will go ahead and run bundle install, pull all the gems in that you need. And it does that every time it does a deploy. So anytime that you change code and deploy again, it's going to reinstall everything that you need. Let's add so this is saying here, do you want these instances in an elastic load balancer? I'm going to add an elastic load balancer before we make this stack so that any instances that I make are going to be automatically added to this elastic load balancer when they are ready. That allows us to have a single point of entry to our application that it's going to be load balanced to multiple instances behind the scenes, regardless of how many we have. If we have 1, if we have 10, It'll only keep instances in the ELB if they are ready, if they're serving a 200. As soon as they stop serving a 200 on their main page, it's going to throw them out of the load balancer, and your customers won't get a 404 error, basically, or a 403, whatever the error is that's coming back. So let's just quickly add a load balancer. It's really easy to do. You just click Create a Load Balancer. We're just going to be serving HTTP, but you could also have it have an HTTPS endpoint. You could choose if it's going to be HTTPS only on the front end, what backend port it's going to talk to. You can have HTTPS on the front end and load your SSL certificate to the ELB and have it talk to port 80 on your backend so that you don't have to actually serve SSL all the way from your instances forward. So basically all the communications would be secure from the outside point of EC2, but from EC2's load balancer back to your instances, it would be unsecure. SSL adds a layer of processing to your application. So you could choose whether or not you want to do that. So we're just going to give it a name, hello DBCx. We're going to say, how does this thing test the instances behind the scenes to see if they're good or not? We're just going to say use HTTP, port 80, and just go to the root directory. We'll just leave the defaults here, but basically response timeout is how long does it take. If your response takes more than 5 seconds to come back to the load balancer, it's going to say, hey, this thing's unhealthy. It's going to say, how often do we check it? We check it every 30 seconds. And how many times does it have to be unhealthy to be kicked out? So after 2 unhealthy requests, kick it out of the load balancer. And then when an instance comes up, after 10 healthy requests, put it back into the load balancer. I'm going to make that 5, so it takes a little bit less time for it to. We'll make it 3. We'll check every 15 seconds. We don't have to add anything here. OpsWorks is going to do it for us. Okay, so now we have this load balancer. The load balancer has a DNS name, which is accessible from the outside world. It's a big long string. You'll generally take this DNS name and make an A record in your DNS server pointing to this, so that you have, hello dbcx.devbootcamp.com points to this record and lets your people from the outside get to you. But for today, we're just going to go with the DNS name they're giving us, because we don't have access to DNS right here. So if we go there, we're going to get nothing. There's nothing running behind the scenes yet. Okay, so let's refresh this page. Now it should know about our load balancers. So now it knows that there's this hello DBCx load balancer that's not being used. We're going to attach it to the Rails layer. Okay, so now we have one layer. It's a Rails app server layer. It doesn't have any instances yet. We're going to add those soon. And it's being backed by this hello DBCx ELB. The health is 0. There's no instances yet. That'll be green when the health is good. So instances. These are just EC2 instances that are being spun up. You could spin them up from EC2 and basically do the same thing with a lot of work. But what's going to happen here is that AWS is going to spin up an instance where you're going to tell it, I want an instance of size X, and I want it to be in this layer. And once it knows that certain recipes will be deployed to that, including your application. Based on which layers that they're in, it knows which applications could be deployed to it. So when we add an application, you're going to see that that it's like a Rails application. It knows that Rails applications get deployed to Rails app layers. So we'll see that in a second. You have a huge amount of choice in which instances you choose to use. There's everything from the smallest micro instance up to extra large compute heavy instances, memory heavy instances. The bigger your instance, the more you're going to pay per hour. So you really want to know, like, especially if you're just developing, if you stick with the micro instances, you're going to be within the free tier. Amazon has a free tier for the first year of use, where you could basically use a lot of their services for free. if you keep your instance sizes small. We're going to do that now. Yeah. So let's add an instance to this layer. We're going to give it a host. It defaults the host name based on the layer that it's in. We're just going to leave that alone. They default you up to C3 large. It's a fairly large instance. But you can see this is what I was talking about. There's a very large number of instances that are available. I'm going to just make a T1 micro, which they've hidden all the way at the bottom, so you don't use it very much. In the advanced section here, they have a few different things. They have scaling type. We're going to use this as 24/7. This is our main application instance. We'll get into scaling a little bit later, where we'll use these other options. But if you have instances that you want to be able to spin up and down manually, that are going to be on all the time or most of the time, you make them a 24/7 instance. And everything else is good. So we just hit add instance. This instance is currently stopped. If I start it, it's going to request it. It's going to take a minute or two for it to spin up. So we'll leave that as it is for right now and wait for it. Okay, so applications. It's not very useful having an instance if you don't have applications to put onto it. So applications are specific by type of application. There's Rails applications, there's PHP applications, Node applications. In OpsWorks, the application is, we'll show you by adding one. We'll add an app. We're going to add this app. So the app name is going to be Hello DBCx. Doesn't really matter what you call it, it's just for your own reference. It's a Ruby on Rails application, but you can see there's other application types you could choose. If you're going to be deploying in a different environment, if you want to have a development environment, you would choose this here. We're going to leave it production for now. It's going to automatically bundle for us. We don't have a data source, but if we did, if we had an RDS instance that we could use as a data source, it'll make the database configuration file for you and fill in the right host name and password and things for you. If you had a OpsWorks layer, which was a database layer, you would click this one, and it would use that instance, whatever instance is in that layer, to fill in the database configuration file. We don't have a database-backed application here, so we're going to leave that alone. And then we tell it where to get the code from. So we can choose Git, Subversion. It can take an HTTP archive from a URL. It can take an S3 archive if you put your code up on S3. Our code's in Git. We're going to choose that. So our code lives at here. My code is public, so we don't have to add any keys. If you had your code in a private repository, you would have to give access keys to OpsWorks for it to be able to use to pull your code. But since we don't have a private repository, it's pretty straightforward. You can tell which branch to pull from. So we're going to be pulling from master. I think that's the default. Very often you'll have another stack that's your development stack, and you would choose to pull from the develop branch here. We'll go into a little bit more about a continuous integration workflow a little bit later. You could set up environmental variables as well too. So this goes into configuration of your application. These get set on the instances when they're deployed to, and you could use these environmental variables to pull things into your application's configuration and not have it stored in your repositories. Everything else is going to be just default here. Nothing else special. Okay, so we have our application. And let's see what state our instance is in. Our instance is still booting, so we're going to give that a few more minutes. Okay, so configuration. Apps need configuration files. we never want to check that configuration into our source code management system, right? That's just dangerous, having our SSH keys or our GitHub, like whatever our secret tokens are. We don't want those things in GitHub because somebody will steal them and hack our system, and then we'll be sad. So what we do is we use the application environmental variables to be able to configure those things. Environmental variables can be set at the application level, as we had seen. They could also be set at the stack level. So if you have configuration that you want to be passed down to all the instances in your stack and be available everywhere, if you go into the stack settings, it lets you put, edit it, this custom JSON here. There's a field where you can just add custom JSON, and you can have secret token. Once that's saved, every time you push to your instances, it's going to, am I missing? No, thanks. So it'll push that down to your instances every time they're deployed, and it'll be available from inside your application to be able to utilize. They just recently added environmental variables to the application level. Up until like a few months ago, the only way to get configuration to your instances was through the stack configuration. So now that it's actually on the application level, it's become a little bit easier to set these environmental variables up and have them be available for you. I suggest using the application level wherever you can. All right, so once your application is set up, and we're actually waiting for our instance still, adding new instances is really easy. You simply go back to your instance button here. You go to whichever layer you're in, and you say add an instance. It'll ask you again, for the same things we had just seen, what's your instance type? Where do you want it to be? What scaling type do you want? Sometimes they boot faster than this. Yeah. So it's very easy to get new instances. And as soon as the instance deploys, it's going to deploy your application code onto it. And once it's up and running, once the application code finishes deploying, which once they get into the next state, I'll show you where it actually does the deployment. You'll see in this ELB link your instances, what state they're in, if they're in the ELB or not. Once they come up and they're ready, you'll be able to actually access your application. All right. Yeah, so layers belong to an ELB. Any instances in that layer will be automatically added to the ELB as they get into a live state. Taking instances offline is just as easy as stop them, and the ELB will recognize the fact that they're no longer serving good requests and pull them out of the ELB. It's almost always the safest thing to use ELB to front your instances, especially your web-based instances. I don't think there's much cost involved. I'm not sure what the cost is, but it's very minimal, the cost of actually having an ELB. And I really want to get my instances up and running before we go into auto-scaling. Yeah. So we'll talk about auto-scaling. There's two different ways to do auto-scaling in OpsWorks. There's time-based instances and there's load-based instances. So if you have a website that, say it's a news website, and whenever new news breaks, you get 50,000 users that come to your site all of a sudden, you're probably going to want to use something that's load-based. What load-based auto-scaling does is it watches your instances, it monitors their CPU usage, their memory usage, things like that, their system load. And you could set thresholds that after it reaches a certain threshold for a certain amount of time, it'll add a certain number of instances. And it's all configurable. And the same thing goes in the opposite direction. After it sees that your instance load has dropped below a certain point for a certain amount of time, it's going to allow you to take instances offline. So if I wanted to add a load-based instance, I'm going to change the host name so I can see what it is. I'm going to say it's load-based. Make this one a medium. All right, so this first app, the first instance that we brought up is now in the running setup state. We should be able to see now what it's doing in the deployments. No, we can't see that yet. We'll see it soon. It's currently getting itself into a running state. So it's booted up. It's got a running system, and now it's basically updating itself. It's getting all of its libraries up to current and all of its applications up to a current state. After this finishes, it's going to deploy the application itself, and then the instance will be ready. So if we go to these two links here are for the auto scaling features. So we just added a load-based instance. If we go to load-based and enable it for our application, so now we have the ability for our app to scale based on load. There's two sets of configuration. There's the up state and there's the down state. So this is what happens. It allows us to choose based on these various metrics that we have, based on the average CPU load, the average memory, the average the system load, the average memory, the average CPU. After X many minutes of being in this state, bring up this many servers. So we could say bring up like 2 servers after the thresholds are exceeded for 5 minutes of the CPU being over 80%. And then scale back down slower than we go up. You often want to get instances up and running as fast as possible in larger chunks to handle the load that's coming in, and then slowly back down to make sure that you're actually meeting demand. Nothing's going to actually happen now because we don't have any load on our servers, but if we did, and we do actually, it's going to spin the server up now. If you look at the monitoring, you'll probably see that since these systems are in a state where they're coming up, they're using a lot of CPU. Yeah, it's not fully reflected yet, but basically, so OpsWorks does monitoring per layer. You can see over your entire layer what the CPU usage is, what the memory usage is, what your system load is. The system load here is 1.2, and it's spiking up high because the system's coming up. And then if you click into the layer, you can see the actual instances, each individual instance, what its load is, what the different metrics are over a period of time. You could change it for an hour up to the last 2 weeks and see how your app has been trending as far as your instance usage goes. And this allows you to tune how many instances you need to keep your app running smoothly. So we have an online app now. This one completed. I think we'll see it in the deployments, maybe. Let's deploy our application to it. So to deploy an app, we go to the Deployments tab, and we click Deploy an App. We choose if we had multiple applications, we could choose which one to deploy here. We only have one. The command is deploy. There's other commands you could send to the instances. You could tell it to undeploy the app that you had just sent out, roll back to a previous version. So when it does the deployment, it keeps the last 4 or 5 versions of deployment of the code on the server, but it only points to the newest one. So you could tell it to jump back to the one before that if you accidentally pushed out bad code. You could tell it to restart the web server, stop the web server. You almost always just deploy. You could also choose which instances to deploy to. In this case, it's only going to it would normally deploy to all the instances in your layer. If you wanted to do like a rolling deploy, you can choose just deploy to this one instance and then go on to the next one. It's choosing only this one now because it's the only one that's in a ready state. The other instances aren't ready yet; they're not up, so it can't actually deploy the code to them. So if I do that, it's going to start spinning. You could actually see what it's doing if we log into the server. But right now, what it's doing is it's pulling GitHub. It's finding out what new code there is. It's pulling that code down, then it's going to install it, it's going to run bundle, and it's going to restart the web server and get you into a ready state. It's usually pretty quick. This application has no dependencies, so it should be pretty quick. So there's also time-based auto-scaling. If you have an application that after it's been up for a while, you see that from 2 p.m. to 5 p.m. every day, you get 3 times the amount of traffic. You can keep your base application at a fairly small level as far as your instance size goes. But for those 3 hours a day, you could spin up 3 more instances, knowing that there's going to be this amount of traffic. It's obviously something you need to know your application and how it's being used to be able to do this. But it ends up being a good way to save a lot of money. So we don't have any time-based instances. We'll add one. To make sure for it to fall into the time-based category, you have to make sure the scaling type is set to time-based. And then you can choose a schedule for when this is actually going to be on. So it's in UTC. You could set different schedules for every day of the week. We'll just say today we want this thing to be on now for the next hour. What should happen is that this instance should start spinning up soon. It schedules itself. It should see it soon and decide to start spinning it up. All right. All right. Let's just get our app up before we go to continuous integration. Let's see how the deployment's going. It's still running. So we can actually log into these instances. We can SSH into them. One of the things that you do in OpsWorks is you set up users. And you can set up for each user what the... I have to make a user. All right. It allows you to push SSH keys to your application so you can log into them and see what they're doing. I'm not really sure why it's not seeing me.